You guys hear me?
Yes, sir.
Okay, so I have been shouting for a minute. Okay, thank you for the response. Okay, I guess you can hear me. So today we are going to see the class lecture 2. I have already uploaded that file on LMS. You can download it from there. Now we are going to use a Word document file to share some information as well to describe the topics properly. So before I show you the class lecture, I need to show you the marks distribution. Maybe in the I'm sorry, maybe in the last class I told you that I'm going to describe the marks distribution once I had that
স্যার
from the paper
আপনার
test.
কথা না
So
খুব
now I
আস্তে
have
আসছে
this
একটু
marks distribution in
জোরে
here.
বলা যেত
So this is the marks. Yes, you can say that again. Sorry, I couldn't hear you.
স্যার আপনার কথা না খুব আস্তে
Someone was
শোনা যাচ্ছে
saying something
স্যার ক্যান ইউ হিয়ার মি
very low. Not even now.
হ্যাঁ স্যার
Yes,
এখন
I
ঠিক আছে
can hear you properly, but I don't. Okay, 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 fine. Okay, so now back in this Word document file, I hope you can see this file. Please confirm if you can see this file.
Yes,
Just
sir.
waiting for your confirmation. Okay, thank you. So this is the mark distribution we are going to use for this trimester. There will be 5% marks in the attendance, 40% in the class test. So we are going to take class tests in this semester, no in-class assignment anymore. So there will be assignment, 10% for assignments. Two assignments will be given, one before midterm and one before the final. Okay. And there will be a midterm examination and final examination. Like the second previous semesters, we used to have midterm and final both. So for midterm, there will be 20% marks. Time will be 1 hour and extra 15 minutes for downloading and uploading the answer script, downloading the question and uploading the answer script. And in the final, there will be 25% marks, and um, it will have only 1 hour and 15 minutes to write your answers, and 15 minutes extra total 1 hour and 30 minutes to do all the things. Write your answers and download the question and upload your answer. Okay. So this is a total 100% marks. I guess there is no confusion. And in the class test, we are going to count 3 out of 4 or 5 class tests we can take. Okay. So this is it. Is there any question related to marks
স্যার 4
distribution?
আর
Any
5
confusion?
মানে এটা কি এখনো ডিসাইডেড না কয়টা দেওয়া হবে
Four or five, not this, not that kind of thing that it is not decided. It is not sure how many we can take because we will have to see how we can progress. If we can progress smoothly, we can take 5 classes. But if we don't have much time to cover the class topics, then we may reduce the class test to 4. Okay, so this is it. Any more questions? No question, fine, thank you. So I'm going to show you this class lecture. This is the second class lecture, and we are going to see some preview of the last class. This was all about the last class, the before midterm syllabus, right? To convert high level language to MIPS. Normally, we are going to, in this course, we are going to see C language codes converted to binary or machine language. And we do know that in our operation, we are going to use two steps to do convert high level to low level or high level to binary. We are going to use two steps. First, high level to mid or assembly language, then mid or assembly language to binary machine language. And who does that? We already know what is compiler, what is assembler is. So this is MIPS architecture we are going to see in this course, the mid-level language, assembly language. Okay. In today's class, at the end part of the class, we are going to see some simple basic C codes converted to assembly programming language instructions. So actually it is codes converted to instructions. Okay, so we are going to see that in the later part of the class. But before I'm going to show you some theories related to computer. We have seen this in the last class, what is assembler, what is assembly language. So I'm not going to show you these things anymore. I just want you to show some theories related to memory and software hardware. Okay. So this is a memory. It has two types of it: primary memory and secondary memory. Primary memory is actually RAM, cache memory. These two things, SRAM, DRAM. I'm going to elaborately describe that in the later slides. So normally memory are of two types: primary and secondary. And primary memory is way faster than the secondary memory, which is hard disk or storage, whatever we say. And our primary memory is also expensive than the secondary memory compared to the secondary memory. And primary memory has another feature, that is it is volatile, and secondary memory is non-volatile. And what is that? For example, I have been using this Microsoft PowerPoint to show you the class lecture slides, right? The PowerPoint files, .pptx files. So actually, I am using an application to show you this file, and whenever I am clicking on the slides, it's opening using the application PowerPoint. Whenever that application is running behind it, that application files are actually loaded onto the RAM. So if I close this slide, RAM will release this memory portion needed to show me these files. Okay, when I clicked on these files, RAM loaded necessary memory portion to show me this slide. Okay, whenever I'm going to close this slide, RAM will going to release that. Okay, so this is RAM. And what is storage? Storage is in our drive C, D, E. If we store something, some photos, or movies, videos, or any kind of necessary files, that will be kept in it. Mm, Storage will not lose its position, never. Even if we turn off our computer and restart. But for example, without even closing this application, if I just turn off my computer and restart, RAM will release all the memory it has in it right now for this slide. Okay, so that is why it is volatile. Volatile means it forgets whatever written on it if there is a shutdown. Okay, so if we shut down our computer and then restarts, it will forget whatever written on it. It will release all the memories of the all application. It will release the memory needed to run the Google Chrome browser, this file explorer, PowerPoint application, MS Word application. It will release everything if we shut down. Okay, but storage will never release these memories. It will never, because it is non-volatile. It never forgets whatever written on it. If I keep this slide file, CA lecture 2.pptx file in drive D, if I shut down and restart, it will be there even after the restart, right? So that is why it is volatile RAM, and secondary memory is non-volatile. I guess there is no confusion in this part, volatile, non-volatile. If
Yes,
there
sir.
is any, you can ask. And our memory hierarchy is like this. CPU means in here generally processor. This is central processing unit, but mainly we understand by saying CPU is processor. So processor is actually directly connected with primary memory, RAM or cache memory, and that RAM or cache memory is connected with the secondary memory. For example, if processor or CPU needs some files to access from the secondary memory, it just cannot get it directly because there is no direct connection between these two. CPU will demand these files in the secondary memory to primary memory, and primary memory will be responsible to bring that demanded file by CPU from secondary memory to CPU through primary memory. Okay, so you can say primary memory is a bridge between the CPU and the hard disk or secondary memory. Okay, so we are going to see what are the type of primary memories we can see. Actually, two: DRAM and SRAM. Primary memory we say RAM, it is random access memory. But in here in the RAM there is two type of RAM. So DRAM, SRAM. DRAM is the dynamic RAM. SRAM is the static RAM. You can see the example sample here. DRAM is the DDR4 RAM of 16 GB, 8 GB, whatever we install after purchasing the computer to enhance the speed of the response time in our computer. Okay, so this is the DDR4 RAM, and this is static. Why it is static? I'm going to let you know about this, but this is cache memory. Okay, another kind of RAM, static RAM. This is cache memory, and this memory is very special. Whether although it is very small in size, like DDR4 RAM is of 8 GB, 16 GB, or 4 GB, whatever it is in gigabytes. But in my laptop, I have only 6 MB of cache memory. So you can see 8 GB RAM, 6 MB of cache memory. It is much lower than the DRAM. Okay, so
স্যার
dynamic.
এখানে স্যার 6 MB ক্যাশটা কি স্যার আমাদের প্রসেসরের সাথে যে ক্যাশটা থাকে ওটা বুঝাইতেছে
it
স্যার?
is it is built in with the processor. We cannot purchase it on our own and install it to enhance the performance. It is already built in with the processor. So if we want a good cache memory, then we have to purchase a good processor. It is built in with the processor. You are right. Okay, so
Sir, in
this is
case of unproper shutdown and our browsing tabs will store in Google Chrome. We can restore it after start the computer again. So how this can store?
okay. Okay, let me tell you something. I'm going to describe everything about that. That you are saying, even after the shutdown, there are some browser we can restore, right? If
Yes,
clicking on
sir.
that, we can restore.
Google Chrome.
That is an extension coming with the Google Chrome browser. That is a feature of the Google Chrome browser. Okay, this is a feature of the Google Chrome browser, not part of the RAM, original RAM. Okay, Google Chrome browser is itself giving this feature with some cookies in it, because whenever we are going to install this Google Chrome browser, it has some cookies. So it has a internal storage that will load all the tabs I have opened in here, like dashboard, attendance entry, Meet, United International University, SQL Laboratory, email section. It will load all the tabs in its cookies, not in the RAMs. That is why we can store
What
it.
does cookies do?
Store something necessary or history part of our browsing. Okay, and even it stores the password. Even we want to save. You guys remember there is some message coming that do you want to save password? Do you want to save password from Google Chrome or
Yes.
any kind
Yes,
of
sir.
browser? And that is those passwords are saved in cookies, not in any kind of RAM or storage you have in your laptop or computer, right? So that is a feature of Google Chrome browser, not nothing to do with the RAM, because RAM will release the memory. Okay, and there are some features in some application. Even I have uTorrent in my laptop, and whenever I restart my laptop, uTorrent pop up. Why? Because there is a check option. I can check it to always open the uTorrent whenever I'm turning on the laptop, right? So it is built-in feature with the uTorrent, nothing to do with the RAM. You get it?
Yes, sir.
Okay, fine. So I'm just
স্যার
going to show you.
স্যার একটা
Oh,
কোশ্চেন
yes,
ছিল।
yes,
স্যার
yes,
ক্যাশ
yes.
মেমোরির ব্যাপারটা স্যার আরেকটু যদি একটু বলতেন, এর
Okay, okay,
কাজটা
okay,
কি?
okay, 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 okay. I'm going to describe the cache memory work now. Let me first finish this difference in between these two type of memories. Then it will be easier for you to understand what actually cache memory does. Okay. So SRAM is static while DRAM is dynamic. Why is that? If you understand this line, you will be able to understand what is actually cache memory. What does it do? Okay. So let me first tell you what is static, what is dynamic in here. Why DRAM or the 16 GB, 8 GB RAM install in our computer, it is dynamic? Because it loads memory portion required to run an application. For example, in our PowerPoint, currently, only this home tab is necessary to show this application, right? So initially, RAM will load the memory portion of the home tab only, not the all tabs. It will it will load this information, okay, to RAM. If I close this, it will release the memory portion. So again, I will have to open it and it will reopen and it will take time to load the home tab in here. Okay, so if I close this application, RAM will release it. That is why it is dynamic. It just always not holds on to something. If I am using it, it is storing the memory portion required to show that file to me. If I am not using anymore that application, it will release the memory. That is why it is dynamic. Okay, it is changing with the time and with the demand of the memory portion. But SRAM is static. Why static means it cannot change with time, right? It is static, fixed. So let me give you an example of the cache memory. You guys do use smartphones and you guys have a cache memory cleaner. You have seen this application once in a life at least.
Yes, sir.
Cache
Yeah.
memory cleaner. Okay. And in our computer, there is a C cleaner as well application, but normally we do not use it. But in our smartphone, we tend to use the release the cache memory. We remove the cache memory to so that our our smartphones actually run faster. So what is actually cache memory? What is that we clean?
Sir.
Why it is static? Let me tell you. First, whenever I start my laptop, first thing I do, I actually open the Google Chrome browser. Have you noticed this kind of things? That whenever I am opening the Google Chrome browser for the first time, it takes longer time than when I'm going to open it for the second time. For example, if I close this Google Chrome browser and reopen it, it will take less time or lesser time than it actually took for the first time. Did you
Yes,
notice that
yes,
thing?
sir.
Why
Yes, sir.
is that? Why is that? Why is that? Because cache memory loads everything we do after the restart of the computer, or even after we turn on our laptop and we do things like I have opened Google Chrome browser, PowerPoint file, Word document file, this file explorer file. Cache memory will loads everything it can within 6 MB of cache memory. Okay, so whenever I am going to close the uh, Google Chrome browser, it will not be able to release that memory from itself because it is static. Once it has loaded the memory portion required to open the Google Chrome browser, it can never release on its own. So cache memory won't be able to release this memory portion required to open the Google Chrome browser on its own. So if we don't clean the cache memory will always have this file of the Google Chrome browser opening memory portion. Okay, so that is why if I close the Google Chrome browser and try to reopen, it will take less time because the file required to open the Google Chrome browser is still in the cache memory. And we do know from these pictures that CPU demands everything. Because if I click to open the Google Chrome browser, that request sent to the processor checks this information in the primary memory, and in primary memory there is a cache memory. Now, if anything is available directly in the cache memory, it will load faster compared to something is in the secondary memory. As you know, the process is CPU is directly connected with the primary memory. If there is something in the cache memory, it will load faster. If there is something not in the cache memory, it has to fetch something from the secondary memory to primary memory, then to CPU, then it will take longer time. So initially what it does, from the Google Chrome backup file, it loads file from secondary memory to primary memory, then to CPU. That is why in the first time, whenever we are clicking on the Google Chrome browser, it takes longer time. And then after that, when the memory portion required to open the Google Chrome browser is in the primary memory or in the cache memory, CPU is taking lesser time to open it. Is it clear why it is static?
Yes, sir.
Okay, okay. So SRAM is static, and other differences are easier. SRAM, we know that a cache memory is faster than
স্যার
normal RAM. Yes.
স্যার ক্যাশ মেমোরিটা বলতে বুঝাচ্ছি যেরকম হচ্ছে যে ধরেন ইউটিউবে হচ্ছে আমরা ভিডিও প্লে করি
Yes, yes.
বা
Those
হচ্ছে
files
সেই
are stored in the cache.
হ্যাঁ সেটা প্রথম যখন আমরা প্লে করি তখন
Yes,
একটু
yes,
স্লো
yes,
হয়, আর
yes,
যখন আমরা
yes,
সেকেন্ড বার প্লে করি তখন হচ্ছে সেটা ক্যাশ কিছু সেভ হয়ে থাকে অটোমেটিকলি, তখন
yes,
হচ্ছে ইজি হয়ে যায় আর কি।
yes, yes, yes. You are getting things perfectly. Okay. So this is the second difference. SRAM is faster compared to DRAM, consumes less power than DRAM, uses more transistor per bit compared to DRAM. That is why it is faster, and SRAM is more expensive. Okay. So these are the differences between SRAM and DRAM you need to notice. And now we are going to see secondary memory. We know secondary memory as hard disks, but there are plenty more. Read-only memory, erasable programmable read-only memory, CD-ROM, CD read or write, flash memory pen drive. We are used to have this, and floppy disks, magnetic tape. These were used in early 90s, I guess. Now it is of no use as there is much more size available in hard disk. So we prefer to use hard disk. Okay, these are the secondary memory which can store some information. Okay, now we are going to not talk much about the theories because we need to see some basics of C codes being converted to assembly language instructions. Okay, so what is instruction set? We are going to see. Okay, and I'm not going to talk much, but I'm going to talk a little bit in here why we are actually using MIPS. Because we have seen there are two kinds of assembly languages we are going to learn, 8086 and MIPS. But why MIPS in here? We are going to learn because it is simple, elegant, and easy to access, easy to use, easy to implement. Everything is easy in here. That is why we are using MIPS. Okay, converting C codes to assembly in MIPS, it is way much easier than in 8086, and you are going to learn it when you are going to complete the lab assembly programming language lab. It is a lot easier in the theories in MIPS. Okay, MIPS is widely used in embedded apps, means it is widely used in private company apps, and you can see the number of MIPS processor manufactured in 2002. So it is actually a famous architecture used by many famous companies like Silicon Graphics, Cisco, Sony, like this. Okay, so that is why we are going to learn MIPS architecture, and this is the first C code. A is equal to B
স্যার এই
plus C.
আর্কিটেকচার গুলো শুধুমাত্র মানে সব কোম্পানি কি ইউজ করতে পারে না, মানে আদার্স যে মাইক্রোসফট বা আমরা যে পাওয়ার
No, no,
পয়েন্ট
no,
ইউজ
no,
করি?
no, 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 no. Our Microsoft use Intel architecture, and that architecture is unknown to us. We do not know what is the inside architecture of it. It is actually private and not widely open to so that we can use it. Okay, so it is a secret. Actually, you can say that their architecture is secret to us. We do not know what is inside that Intel architecture, but we do know how what it means, and we are going to learn that. For example, if you learn how MIPS works, you can be the owner of a new Intel architecture one day. I hope you can build on your own architecture with the basics of MIPS. Okay, so we are going to learn MIPS architecture. So now we are going to see the first C code being converted to MIPS code or MIPS instruction. Okay, so this is the first C code. Let me show you it in a Word file. I need help of the Word file. Uh, this is the C code. A is equal to B plus C. Let me zoom in. Now can you see it clearly? A is
Yes.
equal to B plus C. This is the C code. We need to convert it to MIPS code. That is the first C code we are going to convert. Now our goal is to convert high level C code to mid level MIPS instruction. Remember, code to instruction. We know how to write C code, but do we actually know how to write MIPS instruction? No. So we need to know what is the format, how it is being written, what is the way to write an instruction. If we know, then we can easily convert from C code to instruction. So we have to see all the instruction in MIPS. It is saying all, but actually it is most of the instruction, because there are some differences in the instructions as well. Okay, so most of the instructions have three operands, one destination, two source operands. Okay, it will be two source operands, one destination and two source operands, and the operand order is also fixed, destination first. Let me show you the uh, thing in here. Out of these three variable, we have to find out which one is the destination variable and which two are the source variable? Can you please tell me? Out of these three variables in here in this C code, can you please tell me which one is actually being used to add and which variable is actually taking all the values in it?
স্যার এর মধ্যে স্টোর করছে
স্যার এ হচ্ছে
So,
ডেস্টিনেশন
so,
ভেরিয়েবল আর স্যার বি প্লাস
so
বি আর
we can say A is the destination value variable in that we want to store some value, and B and C are the two source variables in
সোর্স
here.
ভেরিয়েবল
Right?
স্যার।
So destination variable is A and B and C are the two source variables. And in our MIPS instruction, there are three operands, one destination, two source. Okay. So in that order, we can use this as A as destination, B and C as the two source. Okay. And now we have to know what is the instruction format is. We have to know. Instruction format says we have to first write down the instruction name. And what should be the instruction name in here? We know it is destination variable. B and C are the two source variables. What should be the instruction name? Instruction name should always follow the operation being done in here. What is the operation is being done in here? Add, sub, multiplication, division, and or not, nor. What is the operation is being done here? Can you please tell me the operation name? Add, right? So the
এডিশন
instruction name should be add. So instruction name should be add in here. Okay. After that, we are going to use this three operands. As we have seen that in architecture, there is three operands, one destination, two source, and the order is fixed: destination first, then two source. So we are going to say this is actually the format is first instruction name, then destination variable, then we are going to use a comma, then first source variable, V is in variable in here, and the second source variable. Okay, so instruction format is first instruction name, then destination variable, comma, first source variable, comma, second source variable. So we are going to separate all these variables with comma after the instruction name. So in this order, instruction name is at, let me show you in here. So instruction name is at, destination variable is A, first source variable is B in here, and the second source variable is C in here. So now can we convert this type of C code to MIPS instruction like this? Please respond.
ইয়েস স্যার
Okay. So what it would be look like if this
স্যার এটা
was the
কয়েকটা
C
স্টেপে
code?
হয় না স্যার? স্যার অ্যাডটা
What?
কয়েকটা স্টেপে হয় না? অ্যাডটা
No, this is just one instruction. It will add B plus C and store the value on the destination variable A.
ওকে
Okay. So what would have been the instruction if this was the C code? Can you please tell me?
sub BC.
সাব
Right. Sub A, B, C.
This
Right. This should have been the instruction. Okay. And now just changing the code back to its original. Now I am going to do one more.
হচ্ছে MUL আর হচ্ছে ডিভিশন হলে
AV.
কি হতো
Yes, in this way. Yes. You can say that. Okay. Now, if I add one more variable in here, can you please tell me what should be the C conversion of what is the conversion of me C code to MIPS?
আর ABC D
Section
হবে
name
না
plus
লাস্টে
হচ্ছে
What? Yeah.
লাস্টে
Okay.
জাস্ট
So
কমা দিয়ে D হবে না
you are
স্যার
saying that,
ABC
right?
কমা
স্যার থ্রি কম্পোনেন্ট ছাড়া তো স্যার হওয়ার কথা না স্যার, আপনি তো বলেন
Right,
তিনটে
right,
হবে না।
right. You guys are exactly right about this. There has to be three operand. Can be less than it, but not more than it. Okay, can be less than it, but not more than it. So we cannot write these things in here. A, B, C, D. We cannot write this. So how can we do this if we have the limitation of three operands only? How can we still do this?
আবার করতে হবে স্যার অন্য আবার অ্যাড A তারপরে D সেরকম
add A, then
comma D.
mm, but we don't have three operands in here.
Sir, A comma D.
You're suggesting this one?
Yes,
Yes,
sir.
sir, it is.
Okay, so this is correct. So this A has the addition of B plus C, which is this A, source A now, and it is being added with D and storing onto variable A. So this is the correct formula to find solution of this code. So is it clear to you? Please respond if you have any confusion.
Sir, why double A?
This is destination A, this is source A. This source A has the previous value of B plus C added in here. After this instruction, A has the value B plus C. So it is B plus C added with D and
এর
stored in
ভিতরে
A.
বি আর সি স্টোর করেছে এই জন্য এটা দিয়েছে তাই তো
Yes, yes. This A is the source A. This A is the destination.
স্যার ওটাকে উল্লেখ করে দেওয়া লাগবে যে A B আর C
No,
এর
no,
যোগফল।
no. Because
Okay, sir.
you are doing that in here. I can clearly see that. Why you need to mention?
স্যার যদি A ইকুয়াল টু B আর C যোগ না থাকতো, কোশ্চেন যদি দেওয়া না থাকতো তাহলে?
What?
যদি স্যার কোশ্চেন দেওয়া থাকতো A ইকুয়াল টু B প্লাস C প্লাস D, সেক্ষেত্রে?
A is equal to B plus C plus D, right?
জি স্যার, যদি A ইকুয়াল টু B প্লাস C না থাকতো তাহলে?
It means you are saying it is only A is equal to D.
নো স্যার, A ইকুয়াল
Then
টু B প্লাস C প্লাস D, তার আগে A ইকুয়াল টু B প্লাস C এটা দেওয়া নাই।
where it is given that A is equal to B plus C, question is only this single line.
জি স্যার, জি
Solution
স্যার।
is this two instruction.
ওকে স্যার, ঠিক আছে স্যার, বুঝতে পারছি।
Now you got it? Okay.
ইয়েস স্যার।
Okay, now you are good to go to the next problem, I guess. You understand this perfectly. Okay, fine. So now, this is, let me tell you one thing. This is not exactly the correct format of the instruction. Yes, we can see the solution is like that: A, B, C, A, D. Okay, but this is not the correct solution. Why? Because in our C programming, this A, B, C, D variable have some significance. The program knows what is A variable, what is B variable, what is C, what is D. But in MIPS instruction, there is no significance for any variable. Our MIPS instruction does not know what is variable. So can we use it in here in MIPS instruction? Simple answer, no, because MIPS has no significance for variables. It has to have something to store the values of these variables at least. Because if it does not have anything to store the values of these variables, then how can we write any instruction? So MIPS has these 32 registers to store the values of the variables. So in MIPS instruction, we are not going to use any variable names, but instead of that, we are going to use register names. And there is 32 registers in MIPS from 0 to 31. And we can number it like this. And to denote that it is not a variable, it is a register, we have to use this dollar sign in here. To denote it is a register, it is not a variable. Okay. So we can number register from $0 to $31. In this way, we can number 32 registers, but we have to follow a convention in here. And that convention says we have to use variables so that we can identify each register by the name of it. And why is that? Because out of these 32 registers, sorry, out of these 32 registers, there are many types of registers available. But for today's class, we are going to only see 3 types of registers. Out of these 32 registers available in MIPS, there are many types of registers in it. But we are going to see only 3 types of registers in today's lecture. First thing is save register. Save register. And what is save register? Used to store value into variables. So if, for example, in this problem, if we want to store the value of A, B, C, D onto some registers, as we cannot use variable names in instruction, we have to use register. So we have to store the values of these variables onto some registers. So if we want to save this kind of values onto some register, we have to use save register, or you can say saved register, whatever it is, save or saved. Or for declared variables, if I declare few variables, int A, int B, int C, like this, we have to use saved register for declared variables, or it is used to store values into variables. Now, we have to denote this saved register. We have to give this dollar sign to denote it is a register. And to make sure we identify that it is a saved register, we have to use S letter. Okay, S letter. So we are going to number the saved register. For example, if we need 4 saved register, we are going to use S0, S1, S2, S3. Okay, another type of register, that is temporary register, and we have to denote it with a $T0, $T1 in this way, used to store temporary variables. In the next problem that we are going to convert from C to MIMS, we are going to use temporary variables. So we are going to see that. And we are in today's lecture, we are going to see this as well. This is zero register. This is zero register. The name of the register is like this, $0. It has some other name as well, like this $0, but we are going to use $ZERO as the $0 register. Zero register. Okay, it has value of 0. So whenever we are going to need 0 as a constant value, when we are going to see that we will need that 0 value, and whenever we are going to need 0 value, we are going to use 0 register instead. Okay, so first thing first, we are going to store the variables value onto the register using saved register. So for example, if I give you these options in here, if I give you these options in here, that a variable is stored into register $S0, B is in $S1, C is in $S2, and D is in $S3. Can you please rewrite this line for me with the name of the register? Tell me what should be the line instruction in here. My voice reaching you guys? I guess it is. So can anyone please tell me what should be the instruction in here if a variable is stored in $S0, B is in $S1, C is in $S2, and D is in $S3. Can you guys please tell me what should be the instruction in here?
So you have a add
$S0,
$S0,
Okay,
$S1,
so $S0,
S3.
$S0, and হচ্ছে $S3.
S2, right? S0, S1, S2, A, B, C.
জি স্যার, মানে আমি নিচেরটার কথা বলছিলাম।
Okay. It should be $S0, then
S0,
$S0, $S0,
$S.
$3.
Very good. Now we know if this is the C code and this is given in the question that A is in S0, B is in S1, C is in S2, D is in S3, or in the question they ask us to assume necessary register, we have to assume it like this, because these are the normal variables, declared variables, and for this we have to store these variables in saved register. We are going to number it like S0, S1, S2, S3. For 4 variables, we are never going to use S2, S3, S4, S5 like this, never. We have to follow the convention, it will always start from 0. If there is
স্যার
4
জিরো
variables,
মিন্স, স্যার অলওয়েজ কি জিরো মিন্স এ, এটা আমরা ধরে নিব?
no. 0, you have to use the 0 for the first variable out of these 4.
ও আচ্ছা জি স্যার।
For example, if this is like this, F is equal to B, C, D, and you are asked to assume necessary register for this variable. You are going to say f is in s0, b is in s1, c is in
মানে সিরিয়াল
s2,
মেনটেন
d is
করতে
in
হবে।
yes, yes, yes. You have to follow
থ্যাংক
the
ইউ।
serial. Okay, okay. So I'm just turning back to a. Okay, fine. So if this is the C code, we need to convert to means, and this is given in the question, or we have to assume these two lines will be the solution. So I'm just going to drop these two lines in here. The chat box, if you need, you can use it. So this is the solution here. Now I am going to give you one C code. You need to convert it. I am going to give you 5 to 6 minutes, not more than that. And you are going to make some mistakes in that. I know what kind of mistakes you can make. And after you find the solution, like I have given the solution in here in the chat box, you are going to drop your solution in here, the instruction for that C code to mix conversion. And I am going to check each one of your solutions in here in the chat box and let you know who has done it perfectly. And after that, in the Word file, I am going to describe about the mistakes and the perfect solution of that question as well. Okay, so this is the question. Where is the question? Okay, okay, this is the question. I'm just going to delete everything in here about the solution. So this is the question. I'm just going to drop it in the chat box as well. So in case you need, this is the question only. I'm going to explain the question now.
স্যার একটা
It says
কোয়েশ্চেন
you
তো
have
স্যার,
to call.
ব্র্যাকেটের
Yes,
জন্য
yes.
স্যার কি করব আমরা?
Precedence for bracket is at the highest. Okay, you have to do work of the brackets at first, then the rest.
ওকে স্যার।
Okay. So you just cannot add g plus h, then minus I from it, then plus j from, then minus j from it. You cannot do that. You have to
স্যার
use g
আরেকটা
plus h
কোয়েশ্চেন।
first, then I plus j, then minus g I plus j from g plus h. Yes,
স্যার
your
এখানে,
question.
স্যার এখানে হচ্ছে যে আমরা ফার্স্টে হচ্ছে f ইকুয়াল টু 0 ধরলাম, কিন্তু হচ্ছে জি এর মানটা হচ্ছে আমরা 1 ধরবো। এই আগে পরে যেরকম i হচ্ছে নরমালি আগে হওয়ার কথা না, তো এখানে হচ্ছে যে ফার্স্টে যেটা থাকবে
We
সেটাকে
are
আমরা
just
সিরিয়াল
going
মেনটেন
to
করব।
follow the variable.
আচ্ছা
Yes.
স্যার, জি স্যার।
But in that question, it is given that f is in s0, g is in s1, h is in s2, I is in s3, j is in $s4. Now you have to convert. You know what is add instruction, what is sub instruction. Just find the solution of this code and let me know when you are done. I'm just going to stop the screen share to keep track on the chat box, and I'm going to share only that window of the Word file. Okay, so this is it. I'm just going to share this window to keep an eye on the chat box. So whenever you are going to drop your solution, I'm going to let you know whether it is perfect or not. Okay. And in this solution, I may give you a hint so that you do not make that mistake. In case you need a temporary register, you can use it. Okay. Now find the solution and let me know in the chat box when you are done. Okay, by dropping your solution. I'm just going to give you 6 minutes from now on. Exactly after 2:50 p.m., I'm going to start checking everyone's solution. Okay. So I'm just waiting for your solution submission. Okay, Muhibal Hassan Tanvir, Muhammad Tanvir has submitted their solution, but I'm going to check everything after 2:50 p.m. and I'm going to check one by one everyone's solution. Okay, so try and submit once you're done. Okay, so I'm just going to check everyone's solution one by one. Just give me some time. Okay, too many solutions. Okay, good, very good. Okay, first solution is Tarikuddin. What is that? Okay, yes, he might have mistakenly inserted that in here. Muhib Al Hassan is absolutely correct. Perfect solution. And Muhammad Tanvir, you made a mistake in the last instruction. It should
জি
be
স্যার
T2
ওটা টি2
instead of
হবে স্যার।
okay, okay. Muhammad Al Gaddafi, you can never store any instruction in any register. And what is X and what is Y? I have said you have to follow the convention. You only know three kinds of registers: set, temporary, and zero. So there is no X, Y you know about, right? So you cannot use it. And in the sub instruction, it has to be three operands, not two. Okay, so I should check Zulkarnain Shourav solution now. Okay, YK is in S5. Where K comes from in this solution? I cannot see any K. And where is L? What
স্যার
are
আপনি
these?
তো বললেন টেম্পোরারি ভেরিয়েবল ক্রিয়েট করা যাবে।
Okay, but temporary variables means you need not to create any variable. You need just to take the temporary registers. So you will assume there is a temporary register, you are
জি
going
স্যার।
to use that. Okay. No need to use any temporary variables. And for that, you
জি
should
স্যার।
use T0, T1 instead of S5, S6. You got that? Okay. Tarikuddin Tuhin,
ওকে স্যার ঠিক আছে।
next solution is absolutely correct. Okay, fine. Sharper and reverse solution is correct as well. Very good. I didn't expect that you guys will do so good. Gaddafi again not correct because you cannot store any instruction in any kind of registers. Okay, just use the instruction. And instead of X6, Y7, use
স্যার
T0,
ওটা আগেই
T1.
দিয়েছিলাম স্যার।
Okay, your solution is still not okay. Okay, I'm going to check again if there is any solution. Farhan Shahjar will be. Farhan Shahjar will be. What is the sub instruction? S0, S0, S0. It will be 0, right? Because after the first instruction, you are going to replace
ইয়েস
the
স্যার।
S0 in the second instruction, and that S0 has a singular value, not multiple values. So S0 minus S0 becomes a 0 in the S0. So it will not produce the result. Okay, Nazma Anita. Mm, okay, correct. It should be T2, but you guys are using T1, T2, but you should use T0, T1. Okay, you have to use registers from number 0. Keep that in
Okay, sir.
mind. And do not use bracket Atik Shahriyar. Why? After the add instruction, there is no bracket in the format. You should not use it. And again, use T0, T1 instead of T2, T1, T2. Ariful Islam, what is A0, B0? We haven't seen any kind of instruction like this. Only seen save register in the name of $S, temporary in the name of $T, and zero register $0. Afanul Hassan, $XY, use $T0, T1. Gaddafi, why you are using
স্যার লাস্ট না না
$X6?
স্যার ওটা লাস্টে দিয়েছিলাম
Okay,
স্যার।
okay, 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 okay. How many solutions are in here of yours? Abdullah Mamun and Abdullah Mamun, you cannot replace Abdullah Mamun. Your solution, I am going to show it to everyone because in your solution you are making a different mistake, and that is you are replacing the original value of G and I. You are storing G plus H onto the variable G. So you are actually replacing original value of G. You cannot do that. You are going to lose the original value of G in that way. So you cannot replace any variable uh, at the right side of the equal operation. Okay. Muhammad Tanvir solution is correct. Use just T0, T1 instead of T. Sanjana Yasmin Shami S0. You cannot use that. Your second add instruction will replace the first S0. Okay, and you have no T1 in your first instruction. How you are using it in the sub instruction? I'm gonna take a look at that, and remember all the instruction name should be in small letter. Nothing is in capital letter. Faria Javan Jisha solution. From where comes this P1, P2? And we are going to store the values in F variable, right? So it should go to S0, not in X. Maliha Mehjabin Mitu solution is correct. Instead of T1, T2, use T0, T1, Rishad. Adrito Mustafa, I guess it is Adrito Mustafa. Use T0, T1. You have used T0 S1 in the last instruction. It should be T1. And your Ahmed Ammar is making the same mistake, different mistake one. Like replacing the value of original G and I. You cannot do that. And Rashidul Islam Ujjal solutions are correct, but you have to use T0, T1 instead of T1, T2. And again, Gaddafi, not A0, E1, T0, T1.
এটা কি শুধু টি লিখতে হবে?
Yes, always T. Temporary register in the name is T.
Okay, sir.
Okay, so I have checked everyone's solution in here, and you know the correct solution. What should be the correct solution, right? Just wait. Let me copy this file. Copy the solution from here. Okay, I'm just going to show you the solution in here. Okay, just forget about it. Let me. Okay. This is good in here. Okay, fine. So can you see the word file? The solution?
Yes, sir.
This is the exact solution. I have given some comments in here that T0 has G plus H, T1 has I plus J, F has T0. You need not to give these comments in your solution. Okay. Whenever you are going to find the solution, you just never need to give any comments. If that helps you, that is okay, but no marks for comments. Okay. So this is the solution in here. Now we are going to see this instruction. Okay, so we're back in here. So we have seen these two type of registers. Where I was, yes, saved register and temporary register. Now we are going to see the zero register, use of the zero register. Before we see that, we have to be here. Okay, this is it. Okay, let me show you the solution. Okay. Can you please tell me what should be the solution of this C code? What should be the solution of this C code?
Dollar
S0, S1.
dollar S1 dollar. Oh, that's a plus.
Okay, it should be add, right? Or
Yes, sir.
what? Because you know nothing except for add and sub. So that is add for you. Then dollar.
Dollar S0.
Okay, S0. A is in S0. Okay, B is in S1 now. Dollar S1. Then
S2.
in the format we have seen that this is the original format. Instruction name, destination register, source register 1, source register 2. So there is no scope for a constant, right? In our instruction format, we can only see name, destination, source 2. So there is no scope for a number in here. But in here, okay, but in here we have to write 2. Because we don't have a register for this 2 variable, what can we do? So if we have to use a constant instead of a register, we are going to use I sign after the instruction name, I sign, to denote it is an immediate number instead of a register. Is it clear?
Yes, sir.
স্যার আরেকবার একটু বলবেন?
If we are going to use a constant instead of the register, then we are going to use this I sign to denote it is an immediate number. Like let me show you this file. Immediate. For numbers, we are going to use I. Like it is AND instruction, it is AND I. Although we are not going to see any instruction of this logical part in today's class lecture, we are only going to see arithmetic. In the next class lecture, we are going to see logical and then performance related mathematics. After that, data transfer conditional and unconditional. Okay, so just no add instruction available in here, but let me tell you, this is for immediate numbers, constant immediate numbers. Okay, okay, I'm back in here. So for this two, instead of a register, we have to use a I in here. So is it clear?
Yes, sir.
Okay, what should we do for this?
স্যার সাব আই দেন বাকিটা ঠিক আছে।
Okay, so you are saying we should write sub I, but here is a problem. Let me show you what is the problem. Problem
স্যার
is
এখানে স্যার এড দিয়া
in
তারপর স্যার -2 দেওয়া যায় না এখানে?
okay. I'll
জি
come
স্যার
back to
এড দিয়ে
you.
মানে -2।
Yes, I will come back to you. Your solution is correct. I will come back to you, but let me first show you this thing. In arithmetic part, we are going to see arithmetic, data transfer, logical, conditional, unconditional instructions in me. In the arithmetic, we know that there is add instruction, there is add I, there is sub, but there is no place for sub I instruction is in MIPS. So in MIPS architecture, there is no sub I instruction introduced. Why? Then how can we perform this? How can we perform this? So actually, if there is no sub I instruction in the MIPS, there has to be some instruction responsible to do the work of sub I. That is why they have removed sub I, to remove the redundancy, the repeatance. Okay, if some instruction can do both work, so we do not need both the instruction. We better remove the unnecessary instruction. So that is why they have removed sub I instruction, as add I can perform whatever sub I can perform. How? Since is 2's complement. Now let me show you what is 2's complement is. Our computer can perform binary operations and our computer can perform 2's complement. What is 2's complement? For example, this is decimal number 5. In binary it is 101. If we do ones complement, then we are going to convert 1 to 0, 0 to 1. So 101 becomes 010. And then if we add 1 with it, 1 with this number, it will become 110 or 011, which is -5 after the 2's complement. If we do 1's complement, then add 1 with it, it is 2's complement. So if we have a binary number, if we use 2's complement, we are going to get the negative number of that. So it is normal 5, decimal 5, it is minus decimal 5. Okay, so in this instruction, can we not use 2's complement to get this -2 from this 2 value? We have this 2. If we use 2's complement, we can simply get this value in here. And will it work or not? Just please let me know. Okay, fine. So this is the solution for this C code. Okay. Let me give this to you in the chat box as well. Okay. Okay, so I have given this instruction in the chat box. Let me share the full screen. I guess it will be better. I share the entire screen. So were you watching these things in here when I was saying no sub I in MIPS? Maybe not, right?
No, sir.
I was only sharing the Word file, but
Yes, sir.
I was showing you this file. And whenever I was saying that we are going to only see arithmetic, no data transfer, logical condition, and immediate, you haven't seen any of these. Okay, I just forgot to share my full screen. I guess you can see this now. In arithmetic, we have
Yes, sir.
add I, we have sub, but we don't have sub I. Hence is
স্যার এটা তো
2's
জানতাম না
complement. Hence is 2's complement. In MIPS architecture, we don't have that sub I. I was showing you this slide while talking. You guessed I was just talking without the picture. Okay, so this is it. So no sabai. Why no sabai instruction? Because sabai can perform whatever sabai can perform, add I can perform with the help of the two's complement. So this was the two's complement. We have seen this. So this is how we can solve this instruction. Okay. So this is it. Now I am going to ask you to find the solution for this instruction. This C code. Can you convert this C code to me? What will be the solution of this? Remember, we are going to see these three instructions. We have seen these two. In that last C code, A is equal to 7, you need that 0 register. That is $0. It has value of 0. Now, can you please tell me what should be the solution of this C code converting to me?
Sir, $sign Z0 equal to
Sir, add I.
Add I, then assume A is in
Sir,
$S 0.
sir, dollar sign is 0. জি স্যার
Okay, then
comma স্যার
এস
7
জিরো স্যার $0
স্যার শুধু 7
স্যার শুধু 7
only 7.
স্যার না স্যার সাথে
স্যার
$0 হবে না
স্যার
স্যার
জি স্যার
Okay, this
স্যার
will
শুধু
be
7
like
হবে
this dollar 0 and
comma
why is
7
that?
জি স্যার এইটুকুই হবে
Because these are the same thing.
জি
A
স্যার
is equal to 7 means A is equal to 0 plus 7, right? And this
স্যার
0
মানে
is
একটা
in
থাকলে
dollar
অলওয়েজ
0 register. Yes. For any assignments, A is equal to 7 or A is equal to 100 or whatever it is, we have to use add I with a 0 register. Is it clear? Please do let me know.
স্যার এখানে কি স্যার এ ইজ ইকুয়াল টু স্যার 7 প্লাস অন্য কোনো সংখ্যা থাকার পসিবিলিটি আছে সাথে
For example,
7 এর
this
সাথে
how you
প্লাস
are going
দিয়ে
to solve it.
সিঙ্গেল
How you are going to solve it.
টেম্পোরারিতে রেখে তারপরে করতে হবে স্যার এরকম।
No, no, no,
স্যার
no.
প্রথমে 7 করে তারপরে আবার 2 করব।
Then again use add I. Again use add I. Again use dollar $S0. Now dollar $S0 has the value of 7, right? After this instruction, dollar $S0 has the value of 7, right?
জি স্যার।
So now we are going to add 2 with it, sorry, comma, it should be dollar
02
even
স্যার
it is
ফার্স্টে
minus 2, we are going to use minus in here, yes.
স্যার
Anything you want
ফার্স্টে
to know?
স্যার ফার্স্টে যদি কনস্ট্যান্ট থাকে তাহলে হচ্ছে 0 আমরা অ্যাড করব
Yes,
$0
yes,
যেটা লিখলাম
yes, yes. But if that is 7 plus A, if that is 7 plus A, you can, sorry, 7 plus B, for example, B is in dollar $S2. You can use dollar $S2 in here, right? For 7 plus B.
0 পরে $0
Dollar $S0, dollar $S2, 7. B is in, for example, B is in dollar $S2.
স্যার এখানে তো বি দেয়া নাই 2 দেয়া আছে
For B, it will be, for example, for 2, it is correct. It is the solution for 2. I am just dropping this in
স্যার
the
7
chat.
প্লাস 2
This
একটা
is perfect
একটু
solution.
কনফিউশন ছিল
What is the confusion in here?
স্যার অ্যাড আই দিয়ে স্যার ডলার $S0 দিয়ে আমরা স্যার 0 প্লাস 7 যোগ করতেছি
স্যার এই যে
Okay,
এভাবে হওয়ার কথা ছিল না স্যার
after that, what happens?
স্যার
A
নিচে
has the value of 7, right?
জি স্যার
And after that, what happens? A is going to have a 0 plus 2. Sorry, it should be dollar $S0.
জি স্যার
Now it is perfect. Okay.
জি স্যার
So
এবার ঠিক
by
আছে
writing the comment, we are getting it perfectly.
স্যার যদি ওই 2 এর পরিবর্তে বি থাকতো তাহলে হচ্ছে কি S0 তারপর হচ্ছে
Okay, I'm coming back to that. I'm coming back to that. Let me just drop this in the chat box first. Let me write ignore the previous one. And now let me show you. For example, let me delete this thing. If this was 7 plus b, what should be our code? You guys tell me. I'm just going to write add
স্যার
I.
add I s 0 তারপর কমা হচ্ছে $ZERO
No,
স্যার এটা হওয়ার কথা না
can I not use this?
স্যার S2 S1 টা স্যার আমি পরে ইউজ করতে পারতাম না
Sorry, S1. B is in S1. Suppose B is in dollar S1. Whenever there is a constant value, always and a register, always try to write the register first, then the constant value. Always, okay? Even if you do not write, I may give you some, but do not do that. Just follow the convention. This is how we are going to write the instruction. First, all the registers, then the constant value.
স্যার আমি আর কি লিখেছি আর কি একটু স্যার এভাবে হওয়ার কথা মানে কথা ছিল না
If you can solve something in one line, should you try to solve it in two lines, two instructions? If you can find the solution in one instruction, is there any necessity to see if you can solve it in two instructions?
স্যার কনস্ট্রাক্টর কি সরি কনস্ট্যান্টটা কি সবসময় ডান সাইডে রাখবো
Yes, keep that on the right side.
স্যার এতে অ্যাড আইতে দুইটা কনস্ট্যান্ট দেওয়া যাবে
No. If we could add two constant, then 7 plus 2 would have been like this, right? But we cannot do that. That is why we are actually using these things in here.
স্যার দুইটা
No, two constant in
মানে
an instruction is not possible.
আচ্ছা আচ্ছা
In this architecture, you cannot do that. Any more question related to this
আচ্ছা আমি বলতে চাচ্ছি যে দুইটা কনস্ট্যান্ট শুধু দুইটা কনস্ট্যান্ট 7+2 যখন ছিল তখন
Okay.
হচ্ছে স্যার জিরো আলফাবেটিক্যাল জিরো যেটা আর কি ওইটা অ্যাড হয়েছে কিন্তু এখন স্যার মানে আলফাবেটের সাথে হচ্ছে কনস্ট্যান্ট আছে তো এটার সাথে জিরোটা অ্যাড হলো না কেন মানে আলফাবেটিক্যাল জিরোটা
Because we can use directly 7 plus b in math using the add I, right? Like in here, b minus 2, why didn't you use any 0 in here?
ওকে স্যার স্যার
Clear now?
স্যার
Okay. So I guess it is clear to all of you. I'm just going to delete this line in here. I guess it is no longer necessary to show it to you. So I'm going to stop the screen share for now and stop the class recording, as I know I have done with today's class.